So guys, we are continuing with the second session of domain and range. So the first problem over here is to find out the domain and range of f of x is equal to root of x square minus 4. Okay, now we'll discuss the domain over here. Inside the root, whatever value is there inside the root, it has to be greater than or equal to 0, right? Okay, and we are including this particular equal to sign is because it's not the denominator. Fine. Now what we will do is we'll write this as x plus 2 x minus 2, which is greater than or equal to 0. Equate each bracket to 0. X plus 2 equal to 0, x is equal to minus 2, and x minus 2 equal to 0, so x is equal to 2. Okay, so these are the critical values. After getting the critical values, I'll draw a number line: negative infinity, positive infinity, minus 2 and 2. So there are three regions: region number 1, region number 2, region number 3. Take any one point in a specific region over here. There are three regions. Take any one point between the region. So let's go for a simple point, that is 0. Put x equal to 0. Put x equal to 0 in x plus 2 into x minus 2. So this is 0 plus 2 into 0 minus 2. So this is equal to minus 4. Okay. So 0 is the representative of region number 2, right? So the entire region becomes negative because we got a negative 4 as the answer. Okay. Now adjacent region will be positive. This regions will be positive. Okay. Right. Now take a look at this: greater than or equal to 0. Greater than or equal to 0 indicates positive regions. Okay. So that indicates x lies between, x belongs to negative infinity comma minus 2 union 2 comma infinity. Now infinity always has a round bracket. Okay. But then 2 and minus 2 will have a box bracket. That is because equal to is also mentioned over here. Fine. So this is the domain of this particular problem. Let us discuss about the range. Now x square minus 4 is greater than or equal to 0, right? This we have already seen in the domain. Now square root of x square minus 4. Remember our discussion. Square root in this particular chapter, in while finding out the domain and range, do not consider the square root as negative. Do not consider this. This is because if we consider the negative square roots also, okay, then this will not qualify to be a function. This discussion is already done in the first session. Now why we are taking a root is because the question has a root. The question has a root. Okay, right? So this is f of x greater than or equal to 0. This is nothing but f of x, which is equal to y, which is greater than or equal to 0. So y belongs to 0 comma infinity. Infinity is round bracket, and since there is equal to, there is box bracket over here. Fine. So that's the range for this particular problem. Okay. We'll continue with the next problem now. F of x is equal to root of 4 minus x square. The domain, the inside term 4 minus x square is greater than or equal to 0. Okay. F of x is nothing but y. Okay. You can write f of x or you can write y. One and the same thing. Okay. Now inside term is greater than or equal to 0. So 2 plus x and 2 minus x is greater than or equal to 0. Equate 2 plus x to 0. X value is minus 2. Equate 2 minus x to 0. X value is 2. So we'll draw a number line: minus 2 and 2. Consider any one particular point Okay, in any of the three regions, put x equal to 0 in 2 plus x and 2 minus x. So 2 plus 0 into 2 minus 0, which is 4. Okay, so for x equal to 0, we got a positive answer this time. 0 is a representative of the middle region, so this entire thing is positive. Since for 0 we got a positive answer, the adjacent regions are negative. Now look over here, it's greater than or equal to 0. Greater than or equal to 0 indicates positive region. Okay, so x lies between, the domain is x belongs to minus 2 and 2. Okay, the positive region. Equal to sign is also there, so put box brackets. Okay, now previous problem was root of x square minus 4, so there is a difference between 4 minus x square and x square minus 4 problems. Okay, right? Now for whenever the number is first, the range calculation will be different over here. So the range calculation you do in terms of x in terms of y. Okay, not like the previous problem. Previous problem it was x square minus 4, so we used some logic over here by all the steps. Okay, so this thing is not applicable for this problem, right? Whenever a number is there, some number minus x square, so don't use the method of the previous problem. There are obvious reasons behind it. Okay, so we are calculating the range y is equal to root of 4 minus x square. Okay, so y square is equal to 4 minus x square is equal to 4 minus y square, x is equal to root of 4 minus y square. So 4 minus y square is greater than or equal to 0. So 2 plus y into 2 minus y is greater than or equal to 0. Okay, now number line, if you equate 2 plus y to 0, the value of y is minus 2. And if you equate 2 minus y to 0, the value of y is 2. Okay, so now see, take one point, put y equal to 0 in 2 plus y and 2 minus y. Okay, so 2 plus 0 into 2 minus 0, so this will be 4. So for y equal to 0, we got a positive answer. So this entire thing is positive because 0 represents the entire second region. This is the second region. Okay, fine. The adjacent regions are negative. Now y belongs to, okay, minus 2 comma 2. Fine, with a box bracket, since there is equal to sign over here. Equal to sign. Greater than 0 is nothing but positive, so we took a positive region. Okay, and equal to is also there, so we included the values of minus 2 and 2, not a round bracket, we have put a box bracket. Fine, now this problem has some more complexity. Okay, now this y value, it can take only positive roots. I'll explain this. Y is equal to root of 4 minus x square. Now x belongs to minus 2 comma 2, this we have proved. Let's take the value of x as 0, which is within the domain between this minus 2 and 2. So y is equal to root of 4 square minus 0 square, which is root of 16, which is 4. Okay, now this can be plus or minus 4. So when x is 0, y is plus 4 or minus 4. But then if you take negative roots, if you take negative values, this cannot be a function. So y has to be positive, it has to be greater than or equal to 0. Okay, it cannot be less than 0, otherwise it won't be a function. So that gets applicable on the final answer. So we have to discard the negative values. So this negative values we have to discard, so we have to start from 0. Y belongs to 0 to 2. Box bracket, box bracket. Fine, so that's the range for this particular problem. We will take up the next problem right now. f of x is equal to 1 upon root of 9 minus x square. Okay, domain and range we are calculating over here. So domain part 9 minus x square. Now this term is in the denominator as well as it's within the root. So within the root it can be greater than or equal to 0, right? But then since it is in the denominator, it cannot be equal to 0. All these discussions are done earlier as well. Because if the entire term is equal to 0, then the denominator will become 0, right? So 3 plus x, 3 minus x is greater than 0. Okay, critical values are minus 3 and 3. You can equate each bracket to 0, you'll get the critical value. Put x equal to, this time also we are taking 0. Let's take simple value 0, which is representing the second region, in 3 plus x and 3 minus x. In 3 plus x and 3 minus x. So this is 3 plus 0 into 3 minus 0, that is equal to 9. So for 0 we got a positive answer. So this is positive. Okay, this will be negative, this will be negative. Now this time this is greater than 0. Greater than 0 indicates positive, right? So y belongs to minus 3 comma 3. Sorry, x belongs, not y, I'm sorry. X belongs to minus 3 comma 3, right? So that's the domain. That's the domain for this particular function. Okay. So we'll continue with the range. Y is equal to 1 upon root of 9 minus x square. Now first there is a number. It's not x square minus 9. It's 9 minus x square. So always do x in terms of y for such kind of problem. So we'll square both the sides. Y square is equal to 1 upon 9 minus x square. Y square into 9 minus x square is equal to 1. 9y square minus x square, y square is equal to 1. Group all x square terms, and non-x square terms you just isolated. So x square is equal to 9y square minus 1 upon y square. Okay. So x is equal to root of 9y square minus 1 upon y square. So this inside part has to be greater than or equal to 0. Okay. The entire part. Fine. So 9y square minus 1 upon y square is greater than or equal to 0. Okay. So 3y plus 1, 3y minus 1 upon y square is greater than or equal to 0. Fine. Okay. So equate each and every term to 0. If we equate 3y plus 1 to 0, y is equal to minus 1 by 3. If we equate 3y minus 1 to 0, y is equal to 1 by 3. If we equate y square to 0, y is equal to 0. So there are three critical values for this problem. 0, minus 1 by 3 and 1 by 3. So this is minus 1 by 3. Okay, this is 1 by 3 and this is 0. Now this time we are having 4 regions. Okay, instead of 3. So take any one value which is to be tested. So I'll take 1 which is in the 4th region. Put y equal to 1 in 3y minus 1 into 3y plus 1 upon y square. So 3 into 1 minus 1. Okay, I'll just calculate this. 3 into 1 minus 1. 3 into 1 plus 1 upon 1 square. 3 minus 1, that is 2. 2 into 4, that is 8 upon 1, which is 8. Down it is 1 square. Okay, it's not 12, it's 1 square. Okay, so we got a positive answer for y equal to 1. So 1 is the representative of the 4th region. So this is positive, this is negative, this is positive, and this is negative. Fine. Now let's take a look at the inequality. Where is the inequality? Inequality is over here, greater than or equal to 0. So greater than or equal to 0 indicates positive region. So y will be minus 1 by 3 to 0 and 1 by 3 to infinity. Okay. So y will be belonging to minus 1 by 3 to 0 union 1 by 3 to infinity. Infinity always a round bracket. Okay, it can be 1 by 3 box bracket because there is equal to sign over here. 1 by minus 1 by 3 is also box bracket. Okay, but then y cannot be 0 because if you put y 0 over here, everything will be not defined. The denominator will be 0. So 0 will have a round bracket. Now, moreover, for this problem, the discussion doesn't end over here. Okay, since y is equal to 1 upon root of 9 minus x square. Okay, so y cannot be negative. Okay, otherwise there will be multiple images for a single free image. So we cannot take negative values of y. So this part is discarded because this entire set is a set of negative values 0 to negative 1 by 3. Okay, so this is discarded. So the range is actual range is y belongs to 1 by 3 comma infinity with a box bracket. Okay, so we are taking up the next problem. Okay, that is f of x is equal to 1 upon 1 minus x square. Let's calculate the domain. Now the denominator cannot be 0. There is no root in this particular problem. Okay, so 1 cannot be x square. So x cannot be plus or minus 1 by taking square roots. So the domain is x belongs to any real value except plus or minus 1. So that's the domain for this particular problem. Now range. Okay, y is equal to 1 upon 1 minus x square. Just cross multiply. Y into 1 minus x square is equal to 1. Y into 1, that is y. Y into x square, that is x square y, is equal to 1. Y minus 1 is equal to x square y. Separate the x terms. Y minus 1 upon y minus 1 upon y is equal to x square. So x is equal to root of y minus 1 by y. Now the inside term has to be greater than or equal to 0. Okay, so I'll draw a number line. I'll find out the critical values. Y minus 1 equal to 0. So y is equal to 1. That is the first critical value. And equate y to 0. So that's 0 itself. So 0 and 1 are the critical values. Okay, infinity, negative infinity. Right? So see, we have to test one value over here. Let's take x as y is 2. So put y equal to 2 in y minus 1 upon y, the left hand side. Okay, in the left hand side, just put it y minus 1 upon y. So this is equal to 2 minus 1 upon 2, which is half. So for y is equal to 2, we got a positive answer. Okay, 2 represents the third region. It's positive. So this is negative and this is also positive. Okay, now see this. The inequality says it is greater than or equal to 0. So the greater than or equal to 0 are two regions over here. So y belongs to minus infinity to 0 and 1 to infinity. Okay, y belongs to minus infinity to 0 union 1 to infinity. Infinity always a round bracket. Okay, infinity always a round bracket. Now 1 will be given a box bracket because it says equal to greater than or equal to 0. Okay, and at the same time y cannot be 0, otherwise the entire denominator will be 0 and the y minus 1 upon y part will be not defined. So 0 will have a round bracket. Now, unlike the previous problem, this won't be discarded. In the previous problem, we discarded this because the main question had a root. Okay, so this problem will not just discard this because y can take up negative values. Because the main question, take a look at the main question over here, which is given in the right at the beginning. So this does not have a root. Okay, right? So next problem. f of x is equal to 3 upon 2 minus x square. So the domain denominator cannot be equal to 0. So 2 plus x into 2 minus x cannot be equal to 0. Okay. Take the critical values. Critical values are minus 2 and 2. One second, one second. This is not inequality, sorry. So basically, uh, 2 is not equal to x square. Had it been inequality, then we could have done 2 plus root 2 plus x and root 2 minus x. Okay. Sorry. So x is not equal to plus or minus root 2. So then what is the value of x? X belongs to any real value except plus or minus root 2. So that's the domain for this particular. We'll continue with the range part. Okay. So y is equal to 3 upon 2 minus x square. Y into 2 minus x square is equal to 3. 2y is equal to 2y minus x square y is equal to 3. 2y minus 3 is equal to x square y. Cross multiply y. Okay. So x is equal to root of 2y minus 3 upon y. Now the inside part over here has to be greater than or equal to 0. Okay, has to be greater than or equal to 0, right? Because it is under the root. We need to find out the critical values. Equate this to 0. You'll get the value of y is 3 by 2. Okay, and equate y to 0. You'll get the value of y is 0. So 3 by 2 and 0 are the critical values over here. 3 by 2 is over here, 0 is over here. Let's take a point in any one of the three regions, between any one of the three regions. Okay, so I'll take this point as 1 to test. 1 is the representative of the second region. Put y equal to 1 in, put y equal to 1 in 2y minus 3 upon y, in 2y minus 3 upon y. So 2 into 1 minus 3 upon 1, 2 minus 3 minus 1 upon 1, which is minus 1. So when y is equal to 1, we got the answer as negative 1. So this entire region becomes negative. Okay, adjacent regions will be positive over here, right? Now take a look at the inequality, greater than or equal to 0. Okay, so where is greater than or equal to 0? This part and this part. So y belongs to minus infinity to 0 and 3 by 2 to infinity. Okay, so y belongs to minus infinity to 0. Okay, union 3 by 2 to infinity. Now infinity always has a round bracket. Okay, 3 by 2 will have a box bracket because there is equal to over here. And y cannot be 0 because if we put y as 0 in this, okay, denominator will be 0 and will be not defined. Okay, so this is the range for this particular question. Okay, let us take one more example. F of x is equal to x square upon 1 plus x square. Okay, so domain part we are calculating. 1 plus x square cannot be 0. Okay, so x square cannot be minus 1. Now x square will never be minus 1. The square of any number is always positive, so it can never be minus 1. Okay, so that means x will take up any real value because square of any real value is always positive. Okay, so x square can never be negative. Put x ka value as negative, 0 or positive, any positive value, any negative value, any zero value. It can never be minus 1. So x is what? So basically x is any real value. So that's the domain for this particular problem. Range y is equal to x square upon 1 plus x square. Cross multiply. Okay, so y into 1, that is y. X square y is equal to x square. Y is equal to x square minus x square y. Take x square common. Okay, always group the x square terms or x terms to get the value of x. Okay, so y upon 1 minus y is equal to x square. X is equal to root of y upon 1 minus y. So y upon 1 minus y is greater than or equal to 0. It's within the root. Okay, take the critical values. Equate each value to 0. If y is equated to 0, the value of y is 0. If 1 minus y is equated to 0, the value of y will be 1. Let's test one point over here. Let's take 2, put y equal to 2 in y upon 1 minus y, 2 upon 1 minus 2, 2 upon minus 1, which is minus 2. Okay, so when y is equal to 2, we got a negative value. 2 is in the third region, we got a negative value. So this is positive and this is negative. Okay, now see, it's greater than or equal to 0. So we are interested only the positive values. Okay, so y belongs to 0 to 1. Okay, this region. But then we cannot take the value of 1, because if y is 1 over here, 1 minus 1 will be 0 in the denominator, that will be not defined. But then y can be 0. So put a box bracket. So the range is 0 comma 1. 0 is not included, but then 1 is 0 is included, but then 1 is not included. Okay. Yeah. Next question. F of x is equal to x by 2 upon modulus of x by 2, right? So domain. First of all, x by 2, this term cannot be 0. Okay, so x cannot be minus 2, because minus 2 plus 2 will be 0 in the denominator. Modulus of 0 is also 2. So 0 in the denominator indicates that it will be not defined. So x cannot be minus 2. X will be any real value except minus 2. Okay, then we'll find out the range. Y is equal to x plus 2 upon modulus of x plus 2. Okay, now remember, x cannot be minus 2. Okay, so minus 2, if it is not minus 2, x can be greater than minus 2 or x can be lesser than minus 2. So let's take some examples. If x is greater than minus 2, if x is greater than minus 2, let's say it is minus 1, so y will be minus 1 plus 2 upon modulus of minus 1 plus 2. So y will be 1 upon modulus of 1, which is equal to 1. Okay, let's take one more example of this. Okay, let's take x as, let's say, 10 greater than minus 2. So y is equal to 10 plus 2 upon modulus of 10 plus 2. Okay, so that will be 12 upon modulus of 12. Answer is 1, right? Okay, so we got a positive answer over there, and that is 1. Let's take some negative values. X is less than minus 2. If x is, let's say, minus 3, y will be minus 3 plus 2 upon modulus of minus 3 plus 2. So that is equal to minus 1 upon modulus of minus 1. Minus 1 upon modulus of minus 1 is 1. So answer is minus 1. X is equal to minus 5. Y is equal to minus 5 plus 2 upon modulus of minus 5 plus 2. So this equal to minus 3 upon modulus of minus 3 or minus 3 upon 3, which is minus 1. Okay, right? So we are getting only two values. We are either getting 1, we'll get the value of y as 1 when x is greater than minus 2, and we'll get the value of y as minus 1 when the value of x is lesser than minus 2. So the range y belongs to only two values, minus 1 and 1. Okay, so I hope you understood this problem as well. Next question. We need to calculate the domain of this particular problem. Just calculate the domain. Okay, root of a square minus x square. They are asking you to calculate only the domain for this. Inside the root, it cannot be negative, so it has to be greater than or equal to 0. So a plus x into a minus x is greater than or equal to 0. A plus x equal to 0. Equate a plus x to 0. So x is equal to minus a minus x to 0. X is equal to a. Okay, x is equal to a. Now see, this is minus a over here, a over here. We don't know the value of a, but then 0 will definitely lie between a and minus a. So we'll take point 0 to test over here. Put x is equal to 0 in a plus x into a minus x. Put the value of x as 0, so this will be a into a, that is a square. Fine. So this entire term is positive and the adjacent terms are negative. Now since we require greater than or equal to 0, we'll have to consider the positive region. Okay, so that there x lies between minus a to a. Since there is equal to sign and no denominator, both are included. So the domain over here is minus a to a. Just see. Okay, with box brackets, closed interval. Fine, thank you.